This is Diploma in Mechanical Engineering, Engineering Mathematics 3, that was done in July 2022. Question 7b. A function f of t is defined by, this is the function, Roman 1, they want us to sketch the graph of f of t, the interval -1 up to 3, and then determine the Fourier series of the function. Solution. So we have f of t equals to 2 minus t. So we can say that we have f of t equals to y equals 2 minus t. We can create a table here so that we have the value of t and then y from 0 to 1. So when t is 0, when t is 1. So when t is 0, y will be 2. When t is 1, 2 minus 1, y will be 1. So that's the xy plane. So we can plot this. When t is 0, y is 2. We are at that point. And then when t is 1, y is 1. We are at that point, so that's what we have. And then that is the first interval. And then the second interval, we have y equals to t, this second interval. So but the second interval is from 1 to 2. So we shall say when t is 1 and 2. So when t is 1, what will be y? Y will also be 1. T will be 2. Therefore, so when t is 1, y is 1. We are at that point. When t is 2, y is 2. And then we join the 2. So this is the sketch. But remember, they wanted us to sketch from -1 to 3. So this is just one period. So for us now to get the second period, this will repeat itself. Now if I were to sketch up to 3, then the period will start here, end here. So at this point, the period starts again. So it will go down up to 3. So here again, remember the period starts here and ends here. So here, you can see now we have this up to 1. So we shall have that like that. So we have sketched from -1 to positive 3. Now after we have sketched this, we can now proceed to get now the Fourier series. But the sketch is going to assist us because, as you can see, the graph is symmetrical about y-axis. When the graph is symmetrical about y-axis, it means that this one is it means that Pn is 0 because Pn is symmetrical about the point of origin. Therefore, once we have now known that Pn is 0, there's no need of calculating the value of Pn because we know that it's equals to 0. So we can now go on and calculate the value of A0 and An. A0 is given by 2 over t, the integral from 0 to 1, 2 minus t, then plus the second phase, it will be 2 over t. We are integrating from 1 to 2 t dt. So this equals to, but what is t? T is 2, the period is 2, so here we have 2 over 2. Then when you integrate this, you get 2t minus t squared all over 2, 1, 0, plus 2 over 2. When you integrate t, you get t squared all over 2, that given limit. So this equals to, of course, this would be 1, so that we have 2t minus t squared all over 2, then plus t squared all over 2, 2, then 1. So this equals to, we now substitute the limits. We start with 1. When t is 1, we shall have 2 minus 1 over 2. Then minus when t is 0, it will be 0. Then plus, we substitute with the 2. So we have 2 raised to 2 is 4. So we have 4 over 2 minus 1 over 2. So this equals to 2 minus a half plus, this is 2 minus a half. The LCM is 2. 1 into 2, it equals that 2 times 2, we have 4. Minus 2 cos there, it will be 1. Plus 1 cos there, 2 times 2, it will be 4. Then minus 1. So this equals to 4 plus 4 is 8, minus 2, 6 over 2 is equals to 3. Therefore, our A0 equals to 3. Now, our AN equals to 2 over t, then integrating from 0 to 1, 2 minus t cos omega n t dt plus like that. We are getting the constant an. But remember, we know that t equals to 2, and we must also know that omega is given by 2 pi over t. Now, so this will be equal to 2 over 2 will cancel, so that we have the integral from 0 to 1, 2 minus t cos omega n t dt plus, we are integrating from 1 to 2 cos omega n t dt. Now here, this will be our u, this will be our dv, and then at this section, this will be our u, this dv. Now, u equals to 2 minus t, so we get the derivative of u with respect to t, du dt here equals to negative 1. Therefore, du equals to negative dt. dv equals to cos omega n t. So to get the value of v, we integrate both sides of this equation. So when you integrate dv, you get v equals to, when you integrate cos omega nt, you get sine omega nt over omega n. And here we have u equals to t, du dt equals to 1, du equals to dt. And here, the value of u will be equal to sine over omega n. And remember the formula for that is the formula for integration by parts. Now we want to replace this around here. Now our an will be equal to, now we start from here. We are now substituting uv. So what is our u? What is our u at this section? Our u is 2t. This u is 2 minus, remember here, this is u times v. So our u is 2 minus t. Then our v here is this one. So this will be sine like that. Then the limits 0 to 1 minus this side, the integral sine from 0 to 1 v. Our v is sine then our du equals to negative dt. So dot negative dt. So we are through this section. We go to that section plus we apply again uv. our u here is t, our v is this side, so the limit here is 1 to 2, and then minus, drop it there, so that we have minus the integral from 1 to 2, our v is sine, that's our v, then du equals to dt, like that. Now an would be equal to, I want to modify this, 1 over omega n into 2 minus t sine omega n t 1 0. Then this negative and this will turn to be positive, and then we take out 1 over omega n because it's a constant. So we'll have 1, we shall have plus 1 over omega n, the integral from 0 to 1 sine omega n t dt, then plus, again here I'll have 1 over omega n t sine omega n t, those are the limits, then minus, I take out 1 all over omega n, 1 all over omega n into 1 to 2 sine omega n t dt. Our an will be equal to 1 over omega n into 2 minus t sine omega n t plus 1 over omega n. Now, when you integrate this, we shall be able to get minus cos omega n t over omega n yes, then those are the limits, then plus 1 over omega n t sine omega n t from 1 to 2 minus 1 over omega n. Then when you integrate this, you get minus cos omega n t over omega n. So that's what we have. So we are through with the integration. So what we do is just rearrangement. Our a now equals to 1 over omega n 2 minus t sine omega n t, then I can take out this negative sign and omega n, so that I have minus 1 over omega squared n squared, and then you have cos omega n t, those are the limits, plus 1 over omega n t sine omega n t, then take out the negative, so negative and negative will be positive, and then you take out 1 over omega n, so that we have plus 1 over omega squared n squared cos omega nt to 1. Now from here, when we substitute with the sign omega nt, this term will be 0, and also this term will be 0, so that we remain with an equals to, now we have, I can start with the positive. I have 1 over omega squared n squared cos omega nt from 1 to 2, then minus 1 over omega squared n squared cos omega nt from 0 to 1. Now here, our an will be equal to 1 over omega squared n squared, and we can factorize out because it's the same, into cos then minus like that. Now we can substitute omega, because we know that omega is given by 2 pi over t, but our t is 2. So this equals to 2 pi over 2, which is equals to 2 pi. So omega is pi. So this equals to 1 over omega squared n into cos pi n t minus cos pi n t, like that. This equals to 1 over omega squared n squared into, now we substitute the limits, so here we have, well, there is t, we put it there too, so we have cos 2 pi n minus cos, substitute the lower limit, cos pi n, then minus, open the bracket, so where there is t, we put that one, so minus cos pi n minus cos 0. So 1 over omega squared n squared will be equal to cos 2 pi n minus cos pi n minus cos pi n, you remove the bracket, plus 1, cos 0 is 1. So we are saying that an will be equal to 1 over omega squared n squared into cos 2 pi n minus 2 cos pi n minus plus 1 plus 1. So from here, when n equals to 1, that is odd, what will be the value of an? Our an will be equal to 1 over omega squared n squared into, now n is 1, so here we have cos 2 pi minus 2 cos n is 1 minus 2 cos pi plus 1. cos 2 pi is the same as cos 360. Cos 360, that is 1. 1 minus cos pi is the same as cos 180. It's negative 1. So we have minus, this is minus, so minus 1, then plus 1. So this equals to 1 over omega squared n squared into 1 plus 1 plus 1. This equals to 3 over omega squared n squared. So when n is odd, our an is given by that. When n is even, our an will be equal to 1 omega squared n squared into, so n is 2, so it will be cos 4 pi minus 2, this is 2 minus 2 cos 2 pi plus 1. Cos 4 pi equals to 1. Cos 4 pi equals to 1 minus 2 into cos 2 pi this is 1 and plus 1. So it's like we have 1 minus 2 plus 1, which equals to 0, meaning that an equals to 0 and even, meaning that at even numbers the series does not exist. Now let us check again. When n is odd, let us just confirm this. When n is odd, we shall have an equals to 1 all over into, when is odd it means that n is 1, so this is cos 2 pi is 1 minus 2 into this is cos minus 1 plus 1, which equals to 1 plus, this is 2 times 1, we have 2 plus 1 is equals to 4. So that is 4, not 3. For once we have a naught and an the series f of t is given by a half a naught plus, now we have our an, which is 4 over omega squared n squared into, now it's odd, so we start with the 1 when n is 1. Remember, the series is given by f of t is given by a half a naught plus an cos omega n t. Now when n is 1, we shall have cos omega t, odd number, so 3. When n is 3, so we have plus cos 3 omega t, then plus cos 5 omega t, and it continues like that. So this would be equal to, but what was our a naught? Our a naught was 3, so we have 3 all over 2 plus 4 over omega squared. I want to take n inside, so when n is 1, here you have 1 over 1 squared cos omega t plus, when n is 3, we have 1 over 3 squared cos 3 omega t plus 1 over 5 squared cos 5 omega t, and it continues like that. So that is the required series. Remember, we can leave it in omega, or we can, if we want to use pi, remember we say that omega equals to 2 pi over t, which equals to 2 pi over 2. Remember, t was 2, which equals to 2 pi. So omega equals to pi. So we can still write this one as f of t equals to 3 all over 2 plus 4 over pi squared into 1 over 1 squared cos pi t plus 1 all over 3 squared cos 3 pi t plus 1 all over 5 squared cos 5 pi t, etc., etc. Thank you for watching and listening.